Hello friends, welcome to Susan and John MathTube. Today Susan and John brings you exam preparation series lesson number 7. And please note, these videos are specially designed for the first year engineering students who are studying in TU affiliated colleges. So, welcome to lesson number 7, and today we are going to start with multiple integrals. And before we start, as usual, I wanted to read these things and put them into practice. So, let's start with multiple integrals. So, before we start with multiple integrals, the first question is, what is integration? And the answer is very simple. Integration is addition. Not just any addition, but continuous addition. For example, if you think about all the numbers between 1 and 5, there will be infinite number of numbers. And when you want to include all the numbers in some sort of addition, we will use integration. At the same time, if you are worried only about the integers including 1 and 5, then you have to think about only 1, 2, 3, 4, 5. And such summation is called discrete summation, and that is exactly what our sigma does. Okay, now remember, integration always takes a single variable input. That is, single integration means there will be only one variable for our input. At the same time, multiple integral, and the simplest form of multiple integral is double integrals. The double integral will always have two input variables. Basically, a double integral is also summation, continuous summation of course, but there will be two input variables. Now look at this. Two input variables means we have to think about the domains which exist in two dimensions. I'll repeat, domain means input quantities. So the domain for a double integral will exist in two dimensions, and a domain for triple integral will exist in the three dimension. Anyway, I'm sure that you're able to see a lot of points inside the domain. To be exact, there will be infinite number of points, and we have to include each and every point in our double integration. So look at this, the domain contains infinite number of points, and all the points in the domain must be included while evaluating a double integral. Now that's our challenge, and for that what we do is we use two methods. One is called vertical stripe method and the other is called horizontal stripe method. So the first method, you use a thin vertical stripe, and vertical stripe in the sense it should be parallel to the y-axis, and thin, you can imagine the width of that stripe will be so small that the width will be like a point. Or you can think about the area of the stripe being very small that it approaches zero. Okay, so you can imagine a very thin vertical stripe which is parallel to the y-axis. One end of the stripe, I want you to check this picture. One end of the stripe will touch the bottom of the domain, and the other end will touch the top part of the domain. Okay, now you can see that we can draw infinite number of stripes like this. And remember, if you magnify, this will look like a rectangle, but the width of the rectangle is so small, that is why you feel that it's a line. And remember, this gives the limit of y. So the limits of y will be the function value here, and the limit of y here will be the function value over here. Okay, now imagine you're sliding the stripe from the beginning. The stripe begins here, and you keep on sliding it. Of course the height will be different. Even in this picture you can see the height being small here, a little bit large, and low, so long here. So see, the height of the stripe keeps on changing. Now I want you to look at this red dot. When the stripe moves from initial point to the last point, you can also notice some movement in the x axis, and that gives the limits of x. And we have to use these limits and evaluate a double integral. So remember, when you draw stripes parallel to the y-axis, the limits of y will contain variable and x will be a constant. Okay, now look at this. I changed the picture. You can do the same thing. I told you the domain contains infinite number of points, and we have to cover the entire domain. And there are two methods. One is called vertical stripe method and the other is called horizontal stripe method. Okay, so before we start, to study multiple integrals, you must be really good in single integration techniques. And the second thing, you should be able to identify the standard equations of straight lines, circles, ellipse, hyperbola, etc. along with the graph. If you are not really good in it, make sure you are good in these things, and only after that start studying multiple integrals. So let's start with one problem. So, and it's from your past paper. They used to ask this question regularly for years, but not in the recent years, it was long back. Anyway, they are asking you to evaluate double integral over R. Can you read that once more? Double integral over R x into y dx dy. So look at this. There are two input variables x and y, and we are supposed to evaluate this integral. That means we are supposed to add the points in some region R using the function x into y, and the region is the area of the ellipse in the first quadrant. Look at this. They have given the region, that is the area bounded by the ellipse in the first quadrant. Okay, I have to give you one warning. Be very careful. This is not a question where they are asking you to find the area of an ellipse. They are mentioning that capital R is the region, or capital R is the area or the portion in the first quadrant of the ellipse. So I have seen students who just take a look at this area and they read ellipse and they evaluate the area of the ellipse. So don't do such mistakes. So the first thing to do is you have to draw a graph. So we have the ellipse x square by a square plus y square by b square equal to 1, and I'm sure you know to draw the ellipse. So this is our origin, and this is the semi-major axis, and this is our b. And the question they should have mentioned a greater than b. Anyway, let's assume this is our ellipse. Okay, now I'm not interested in the whole part of the ellipse. I'm interested only in the first quadrant because it's given first quadrant. So let's cut it and make it the first quadrant. Now I told you before, this contains infinite number of points. There are infinite number of points in this region. I'll repeat, there are infinite number of points. So if you want to include all the points, there are two techniques. One is you draw a vertical stripe, and method 2 is you draw a horizontal stripe. Anyway, I prefer vertical stripe. So I want you to focus on this. So we have our x-axis and the y-axis and the first quadrant of the ellipse, and the equation of the ellipse is x square by a square plus y square by b square equal to 1. And I want it to be very clear with the equation of x-axis. Equation of x-axis is y equal to 0, and equation of y-axis is x equal to 0. Anyway, let's start. Now look at this. This stripe is parallel to the y-axis, and that means y will have variable limit and x will have constant limits. And here the x value is 0, and here the x value is a. So clearly x varies from 0 to a. And you can look at these stripes. The bottom of the stripe is on the x-axis. You can think about stripe anywhere in the given region. Given region means first quadrant of the ellipse. So the bottom point of the stripe is on the x-axis, and the topmost point is on the ellipse. I'll repeat. In the direction of y, we can see that each and every stripe, let it be the longest one or the shortest one, the bottom point is touching the x-axis and the topmost point is touching the ellipse. So clearly x varies from 0 to a, and y varies from x-axis to the ellipse. Now what is the equation of the x-axis? Equation of x-axis is y equal to 0, and the equation of ellipse is x square by a square plus y square by b square equal to 1. It's given in the question. Now I want the limit of y. So what I do is, using this equation, I will extract the value of y. See, y square by b square equal to 1 minus x square by a square, and that means y square equal to b square by a square and a square minus x square, and that gives me two options. Y is plus or minus b by a into root under a square minus x square. Now look at this. The equation of ellipse is written slightly differently because I am trying to find the y values. So we have equation of x-axis being y equal to 0, and equation of ellipse being plus or minus b by a root under a square minus x square equal to y. So now look at this. We are in the first quadrant, and in the first quadrant y will never be negative. So that's it. Our limits are x varies from 0 to a and y varies from 0 to plus b by a into root under a square minus x square. I'll repeat once more. We had two options, but I took the positive option because we are in the first quadrant. Okay, that's it. And when you write the limits, be very careful. The inner limit should contain variables. And since the stripes are parallel to the y-axis, y will contain variables. And of course, the outer limit will be constants. And since the inner limit belongs to y, we should write dy first, because we are going to integrate with respect to y first. Okay, now I hope you remember integral y to the power n dy is equal to y to the power n plus 1 by n plus 1 plus c. So integral y to the power 1 dy will be y to the power 1 plus 1 by 1 plus 1 plus c. So let's move on with integration. Okay, now in the next step, I'll put a circle so that you find it easy. I'll put the upper limit minus the lower limit. And if you want, you can keep that 1 by 2 outside. So upper limit minus lower limit, and I am keeping the constants outside the integral. Now let's apply distributive property, and that gives me a single integration. And you have already learned single integration, and there is nothing much to do. Integrate, put upper limit minus lower limit, and that's it. Okay, let's try one more example in this video. Okay, so evaluate double integral xy times x plus y over the area between y equal to x square and y equal to x. So I'll keep the question over here, and the first thing to do is you have to find the point of intersection. Remember, whenever they give you two distinct curves, the first thing you do is you find the point of intersection so that you can have the rough figure with points of intersection. Okay, so I'll write the equations. Now tell me, how do you find the point of intersection or points of intersection? Yeah, it's simple. You solve the equation simultaneously and you'll get the point of intersection. And in this case, it's really easy. You can combine it. Y is equal to x. You put the y value here, you get x is equal to x square. Now take everything to the left side or the right side as you wish. I took everything to the left side, and that means either x equal to 0 or x equal to 1. Now look at this. You can substitute these x values in here or in here. Anyway, if x equal to 0, y is equal to 0 because both are equal, and if x equal to 1, y equal to 1. So the points of intersection are 0, 0, the first pair, and 1, 1. And remember, 0, 0 is one point on the two dimension, and 1, 1 is also a single point on the two dimension. Okay, now let's have the actual picture. I hope you remember y equal to x square, because the degree of x is 2 and the degree of y is 1. That means it's a parabola. And one more thing, since we have x square, it will be symmetric about the y axis. So this is our parabola. Oh, I had to change the color. So this is our parabola, and I'm sure you recognize the line y equal to x. Y equal to x means it's a line passing through the origin, and the inclination with respect to the x-axis is 45 degrees, and that's our blue line. And we already proved that the points of intersection are the origin and 1, 1. See? Now the picture explains it. Okay, now look at this. There are infinite number of points in this region. This is the required region. There are infinite number of points, and there are two methods to evaluate or calculate all the points or to find the limits. One is you draw a stripe parallel to the y-axis. Another is draw a stripe parallel to the x-axis. Anyway, I took a stripe parallel to the y-axis. And remember, practically it looks like a rectangle, but theoretically these stripes are so small it will look like a line. Okay, now when the stripe moves from the initial point to the final point, you can look at the projections on the x-axis. I had colored it with yellow. So clearly the limit of x will be from 0 to 1. You can check it. When the point is here, the projection is here. If the stripe is here, then the projection will be here. If the stripe is here, then the projection will be here. So basically x varies from 0 to 1. And y means the bottom point to the top point of the stripe. You can check any stripe in this region. the bottom point is touching the parabola and the topmost point is touching the line. So that's why I wrote here it's from parabola to line. Now what is the y value from the equation of the parabola? X square. So that's it. Now it's evaluation time, and it's very easy. And make sure you write the limit which contains variables as the inner limit. Okay, now let's distribute these quantities, and we get x square into y plus x into y square. Now integrating with respect to y, because we will always evaluate the inner limit first. So I hope you remember integral y power 1 is y square by 2, and that is how we got this y square by 2. Similarly y cube by 3, and you can put the upper limit and lower limit, and then apply a little bit of distributive property. Okay, now I'll write the same step over here. Okay, now it's a single integral and you know what to do. Okay, but I'll integrate one term for you, x to the power 4 the whole divided by 2 dx. Actually this will be 1 by 2 integral x to the power 4 dx, and that will be 1 by 2 into x to the power 5 by 5 plus c, and that simplifies to x to the power 5 by 10 plus c. So look at this. The first one integrated will give you x power 5 by 10. So when you integrate the second one, you will get x to the power 7 by 7 into 2, that is 14, and here you will get x to the power 5 by 15, and here 8 by 24. Now that's it. Put upper limit minus lower limit. Take a calculator, or otherwise you simplify, take LCM, etc, etc, etc. You will get 3 by 56. Anyway, this was a very short video, but I'll be back with more videos in multiple integrals, and we will be discussing the polar integrals and area between two curves, and the main topics, change of order and changing into polar. So I'll be back soon. Till then, bye.